Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of converting units. This is standard 7.4E in the great state of Texas, and we are using item number 24 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we've got Chloe here. She's 5 feet 4 inches tall. Inside each of those inches is 2.54 or 2 54/100 centimeters, and then we need to change her height into those centimeters there. So we're converting units, but instead of within systems, right, we've got a customary set of units here, the feet and inches, and we need to switch that into our metric. So that's something new we do in 7th grade. And so you see the conversion here is between inches, but Chloe's height is given to us in feet and inches. So there's one little step that we're going to need to know how to do ahead of time. Is we're going to need to take our feet and inches and turn them straight into inches. So let's copy that correctly because it's 4 inches, not 2 inches. We need to know that within each of these feet is 12 inches, right? So that's the one thing we're going to need to know. It is on our mathematics chart, but we've been knowing that for a while now. 5 times 12 makes 60. So the 5 feet is really 60 inches, and then I've got my 4 inches. So let's just use 64 inches as her height. That's going to be a little bit easier for us, because now there's a few different ways that we can solve this now that we've got our height in just inches. And you might not think of it originally, but we can actually use our equation here for changing rate here. So we have our y equals kx. Remember, our x is our independent variable. So this gets things going. This is where we're going to start. And what we start with is we start with her 64 inches. So let's put our 64 inches right there. That is our independent variable. That's our x. Now our k is our constant. So that's the rate change. That's the constant of proportionality. And you know what? They actually give us that. That constant is actually going to be this 2.54. And so we don't actually have to find the constant. Sometimes that's what we have to do. In this case, they give it to us. So it's going to be 2.54 because they told us that for every inch, you've got 2.54 centimeters. And we need to find her height in centimeters. So that's our dependent variable. And our dependent variable depends on what we start with, x, and what we do to it with k. So that's just our y. So it's as simple as multiplying 64 times 2.54. So let's go ahead and do that here. 64 times 2.54. You know what? I'm going to go ahead and put my 2.54. Since it's got 3 digits, let me put that on top. It's going to make a little bit more sense. So 4 and 4 is 16. That's 21. And that's 8. That's 10. Always get rid of those. Let's do times 6. That's going to be 24, 32, and that's 12. That's 15. All right, so let's add these up here. We got 5, 2, 6. There we go. So 1, 6, 2. We get 2 digits behind the decimal here, 2 digits behind the decimal. So 162 and 56/100 centimeters. Now, there's another way to do that. If you didn't want to use this equation right here, you can make a proportion, right? So you can say 5 feet, 64 inches. I'm going to go ahead and put my 64 inches, right? And that relates to y centimeters. We don't know how many centimeters that is. But we know our conversion is 1 inch, right? Because we put inches with inches on the top, and 2.54 centimeters. So that's our ratio. You can find a proportion here, and guess what we end up having to do? Multiply those two to find y. Either way, your answer here is H.